Now we're going to determine the velocity vector v of t, and that velocity vector is equal to the first derivative of the position vector. So we can write it kind of like this. Or where we're going to write it, we're going to write it the first derivative with respect to t, d dt of t, because that's the x component. We're going to have d dt of the y component, which is 2 sine t, and the first derivative d dt of the z component, 2 cos t. Now the first derivative of t respect to t is just going to be 1. Because if you had x and you were getting dy, if y equals x and you were getting dy dx, well, the answer would be 1. So it's the same here. 2 sine t, I'm looking at page 25 in the logbook, and sine differentiates to cos. So we're going to end up with 2 cos t there. And cos differentiates to minus sine. So minus 2 sine t there. So that there is the velocity vector. Now, the velocity, if we want to get the magnitude of the velocity, is equal to the speed. So the speed s equals the magnitude of the velocity, something like this, and that's going to be equal to the square root of the dot product. And that all sounds very tough, but basically we'll be doing something like this. So that'll be the square root. We'll be taking the first component there and squaring it. Then we'll be adding in the square of the second component and the square of the third component. And that comes out then at the square, when 1 squared is 1. Square this guy and you get plus 2 squared cos t squared, and the square goes up there. And minus 2 squared is going to be, well, we'll just leave it in brackets there for a minute. Minus 2 squared sine squared t, right? I'm going to make even more space here now. And we get square root 1 plus 4 cos squared t plus 4 sine squared t. Now we can factor out the 4, so we get 1 plus 4 times cos squared t plus sine squared t. You can see now if I multiply back into 4, I'd end up back up there. So that's a valid move there. And cos squared t, cos squared x plus sine squared x, no matter what, it's an x, a y, a t, or a z, that always equals 1. That's a trigonometric identity, and that's on page 13 of the tables, or it'll be in the back of your exam paper as well, perhaps. So we can call that 1 plus 4 times 1, which is equal to root 1 plus 4, which is root 5. So root 5 is the speed, or the magnitude of the velocity. Then the next bit of the question, now the acceleration vector is equal to the first derivative d dt of the velocity vector, which we've already worked out. So our velocity vector, the 3 components we got there were 1, 2 cos t, and minus 2 sine t. That's our velocity vector. So we're going to be getting d dt, the first derivative of all those 3 components with respect to t. So the first derivative of 1 with respect to t, that's just a constant, it's going to 0. cos differentiates to minus sine, so we get minus 2 sine t here. And sine t differentiates to cos, so we get minus 2 cos t in this position. And that is our acceleration vector. And again, to get the magnitude of the acceleration vector, we'll be getting the square root of the dot product. So the magnitude of the acceleration will be equal to the square root of the dot product. So that's the notation for it there. And that looks like this in reality. 0 multiplied by 0 will be given as 0 squared. Plus this minus 2 sine t. That guy multiplied by itself, so it will be squared. Plus minus 2 cos t multiplied by itself, so it will be that guy squared as well. Now I'm just looking at that cos t, cos, what's the minus sign? Yeah, I think we're okay. So that can be 0, forget about that. Then we'll have 4 sine squared t plus 4 sine squared 4 plus 4 cos squared t. And again we'll be able to sub out the 4 there. So we're going to sub out the 4 and we get root 4 times sine squared t plus cos squared t. And we saw earlier that this equals 1, so that's root 4 times 1, which is root 4, and the square root of 4 is 2. So this is our acceleration, the magnitude of our acceleration. So we just finished part 2 there, and for the magnitude of the velocity, we got what did we get? We got root 5, and for the magnitude of the acceleration, we got root 4, which is equal to 2. And then in part 3, they're asking us find both the velocity and the acceleration of the particle at the time t equals pi over 2. Well, it seems to me that the velocity and the acceleration are constant the whole time. That doesn't make sense, does it? Right, so I'm not sure that this is relevant, t equals pi over 2. It seems to me that from our earlier calculations, no matter what's going on, we have a velocity of where we are. What value t is, we have a velocity of root 5 and an acceleration of 2 units. So maybe someone can get back to me to figure out a better answer for that part there. Part 4 here, find the equation of the tangent line to the path of the particle also at t equals pi over 2. Well, something like this. Q omega equals this guy plus omega times the first derivative. Right, so we have a positional vector there given to us, t, 2 sine t, and comma 2 cos t. And we've already worked out earlier the first derivative of this, and that was 1, 2 cos t, and minus 2 sine t. So we put this guy in here, we have t, we write it in this kind of format here, yeah, 2 sine t, comma 2 cos t, plus omega times 1, 2 cos t, minus 2 sine t. And we multiply, we tidy that up then, so the first bit here stays the same. 2 sine t, 2 cos t stays the same for the time being. And then we have omega times 1 is omega. And the second component becomes 2 omega cos t. And the third component becomes minus 2 times omega sine t. Then putting them bits together, we have t plus omega, comma 2 sine t plus 2 omega cos t. And the last bit is going to be 2 cos t minus 2 omega sine t. And we're asked to find the equation of the tangent line. So this is the equation of the tangent line. But when t equals pi over 2, we have to find the value of this. Right? So when t equals pi over 2, at t equals pi over 2, this becomes pi over 2 plus omega, comma, 2 sine pi over 2 plus 2 omega times cos pi over 2, comma, then we have 2 cos 90 degrees or pi over 2 minus 2 omega times sine pi over 2. And we're going to tidy that up a bit further because we can work out values for sine pi over 2. Sine, if we go to page 13 on the tables, it's handily laid out there. Sine pi over 2 is 1. So the first, the x component pi over 2 plus omega stays the same. Then we have 2 times 1, which is just going to be 2 plus 2 omega times cos pi over 2. Cos pi over 2 is 0. So this guy here goes to 0. So we're just left with 2 there for the middle component. Comma. Again, 2 cos pi over 2 is 0. So this guy here goes to 0. And we're left with minus 2 omega. And sine pi over 2 was 1. So that's our answer there, as far as I know.